There's a relationship between delta G and the equilibrium constant, and that's what we're going to investigate in this problem. In this problem, we're given a reaction and we're asked to calculate the value of the equilibrium constant if we're given delta G. So we've already calculated that delta G at this temperature is a negative 142 kilojoules, and we want to know what's the value of the equilibrium constant. Well, the first thing we need to do is we need to make sure that delta G is converted into joules. The reason for that is because R has the units of joules, okay? So make sure that it's calculated in joules here. If you plug in kilojoules, your answer is not going to make sense, right? Because kilojoules will not translate to a R value that's in joules per Kelvin. Okay, so we use the relationship delta G is equal to negative RT natural log of the equilibrium constant. Make sure that our delta G is in joules, plugging that in. R is a constant, negative 8.314 joules per Kelvin. And then where did this 303.15 come from? Well, the temperature is 30 degrees Celsius, right? So we have to convert that to Kelvin. Again, if we don't make that conversion, our answer won't make sense because R is in joules per Kelvin. So if we are multiplying joules per Kelvin times degrees Celsius, our answer will not make sense. All right, so we multiply these two values together. So negative 142,000 is equal to negative 2,520.3 times the natural log of K. So that means when we do our condensing, natural log of K is equal to 56.34. How do we get rid of a natural log? We raise e to that side, right? So e to the ln, that cancels out, is equal to e to the 56.34, which is a very, very, very large number. If your calculator won't compute e to the 56th, depending on which kind of calculator you have, it may not. You could leave it as just e to the 56th. That works. That is an actual number. But if your calculator can compute it, that's a big number, 2.9 times 10 to the 24th. So having a value for the equilibrium constant of 2.9 times 10 to the 24th means that this is an extremely product-favored reaction. And that makes sense given the value of delta G, right? Delta G was a large negative number. So it made sense that we'd have a very, very large value for the equilibrium constant.